The Swarm platform provides a solution for many applications. However, batteries for Swarm Robotics still face a challenge. Replacing batteries across the entire swarm is costly and impractical for many deployments. Batteries often containing toxic chemicals can result in serious environmental hazards. Traditional rechargeable batteries require long hours to recharge, leading to reduced operational duty cycles. In this work, we introduced CapBot, a battery-free swarm robot powered by supercapacitors. CapBot can fully charge in 16 seconds and operates for up to 51 minutes, with a duty cycle efficiency of over 99%. It can carry loads up to 2.5 kilograms, wirelessly controlled, and both its hardware and software are open source. We have developed the CapBot prototype. It includes wireless dock, a power button, 4 DC motors with encoders. Expansion socket can support Adafruit and Arduino connector. Capacitor area, separated traffic lights and charging boards installed on the mainboard. CapBot's infrastructure charging is powered by a 40-amp power supply. In this work, we propose use a higher supply voltage and monitor the capacitor internal voltage in real time to speed up its charging. Normally, a 3-volt capacitor charges to 2.9 volts in 64 seconds. Using the supercharging method, we've cut the time down to just 16 seconds. As shown in the figure, when CapBot operates at different speeds, its autonomy ranges between 51 minutes to 65 minutes. We support energy sharing between CapBots through a process called traflex. This allows CapBots to flexibly transfer energy. As shown in the figure, it takes several seconds to reach 80% of energy balance. We have also explored different bumper connections to find a simple and more effective way to achieve it. You will see our CapBot, the load-bearing test. The CapBot soft stack is built as a library on top of Zephyr. The API provides functions for power monitoring, remote control, and speed regulation. We've also developed a visual console for remotely controlling multiple CapBots. Its interface allows users to track real-time data, such as current voltage, speed, direction, and more. We've built 50 CapBots, which have been used to teach 3 master-level courses at Leuven. The platform has consistently demonstrated reliability in an educational setting.